Okay, so this is a really short video. All we're doing is computing Cohen's d for a two-sample t-test. We'll talk about this really quickly. So the standard deviation from the two different groups they're using has to be averaged together. Um, if you have different sizes in each group, it's going to make this harder to deal with, and you have to follow this formula here. But if you have the same sized group, all you have to do is average the two standard deviations together. It's really pretty simple to do that, right? Um, you can follow this formula if you have different sized groups. I can walk through that with you at the very end of this video, but really what you're going to want to know is what I'm going to show you first, because that's not going to come up very often. So let's go over to Excel. This is what we've been working on from before. So the Cohen's d, the first thing that we have is x1 minus x2, x bar 1 minus x bar 2, I should say, which is the same thing as the numerator for the t-test. Now, if you are using the data analysis tool pack, you don't necessarily know how I got there, so that's okay. What we're going to do is we're going to put in, well, we could just say d numerator. This is for Cohen's d. And we're just going to put in equals and find your species 1 minus species 2. There's our numerator. Now our d denominator is, again, literally just the average of the standard deviations. Now, before we do that, we can come over here and we could compute the standard deviations from the variance. All we have to do is say equals SQRT for square root of this variance right here. And then we can pull that over and get the standard deviation for the second group as well. So in the denominator, all we're going to do is say average those two standard deviations, and there we have 10.68477. Okay, well, Cohen's d is so simple. All you got to do is put the numerator over the denominator, and there's your Cohen's d. Cohen's d in this case is 0.47. It is a medium effect. It's not huge, but it's not tiny. So it's just a medium effect. All right, that's it. Now, if you want to get harder with what we're doing here, you want to make the calculator with all this crazy stuff, we can. I'm going to make a different denominator here. We're going to start with SQRT, and then we're going to put one bracket for this whole numerator of just pooled variance here. Okay, and now I'm going to put a bracket for this whole phrase before the plus sign. And now I'm going to put the bracket that's actually here, n1 minus 1. Okay, well, n1 we can get from our output right here. It's just in cell I6, so that's great. And we're going to say minus 1. And then we're going to multiply that by the variance for group 1. So there we go. And now we're going to add another phrase just like that. So I'm going to open two more parentheses, and the n for group 2 is right here, minus 1 multiplied by the variance for that group, which is right there. Close that one, close that. Now that was for the top of everything. Now we're going to throw in division sign, and I'm going to put one bracket for everything on the bottom there. N1 is this 20 plus n2, which is this 20, minus 2, which is just a constant. We're going to close our parentheses. We're going to close the last parentheses, which is the one for the square root. And there's our denominator. It's a little different than taking the average of the standard deviations. And that's to be expected. There's some slight mathematical differences that can come from following the formula versus just taking the average. But it should be close to the same, but it's not exactly the same. But if you did have two different n's in your two different groups, this is what you'd use. So if you followed that to get your Cohen's d, you're just going to put 5 divided by this denominator. And the Cohen's d is pretty close to what it is using the other method, so within rounding error. Okay, that's it for the Cohen's d for independent samples t-test.